So now we're going to look at what happens if events are not mutually exclusive. So events A and B are not mutually exclusive. If that occurs, then their intersection is not the empty set. That means there's something in the intersection, something that can happen. There's some element of both of those sets that can happen at the same time. And the probability of their intersection is not zero. All right, and so that means that it's possible that you could get both occurring. Give an example with the deck of cards. If H is a set of all hearts and F is a set of all face cards, then if I pull one card up, it's possible to be both a face card and a heart at the same time, like a King of Hearts. Okay, so that's possible. Now face cards, I'm including just Jack, Queen, King there, not the aces. All right. So that means that in this case, the intersection of the two, H intersect F is equal to the Jack of Hearts, the Queen of Hearts, and the King of Hearts. So there are three elements of that set. That tells us that the probability of the intersection, the probability that you have both, is 3. There's 3 in that set. 3 out of 52. And 3 out of 52, never mind, that doesn't reduce. It's just 3 out of 52. Now you could get the decimal form of that. It's around 6%, just under 6, like 5.7, 5.8% probably. I was just estimating. So, anyway, so that's your probability of the intersection. But now let's look at the OR, right? Let's look at the union. So the probability that H occurs or F occurs, so you get a face card or you get a heart, is equal to the sum of the two, close to equal to the sum of the two. If you add the two up, you're double counting the ones in the intersection, right? So if you add up all the hearts, well, there's 13 of them. If you add up all the face cards, there's 3 of them. But there are 3 that are in both of those sets, so you're double counting those 3 cards. And so what we want to do is we don't want to double count them, we only want to account for them once. And so if I'm double counting them here, if I subtract one copy of the intersection, that will remove that second copy and you'll only be counting them once. So I'm going to remove a copy of the intersection, okay? So the probability of H or F is the probability of H plus the probability of F minus the probability of their intersection, okay? So in other words, the probability that I get a heart or a face card is going to be, well, the hearts are 1/4 of the deck. The face cards, if you think that one through, there are 3 face cards for each suit. There are 4 suits, so it's 12 face cards. So it's 12 out of 52. And then I have to subtract off the 3 out of 52. Right? Now, if I were to build this first fraction up, it's actually 13 out of 52, right? 1/4, 13 out of 52. I'll just do everything out of 52 so I have a common denominator. And then add and subtract. So 13 plus 12 is 25, minus 3 is 22. So we end up with 22 out of 52 is the probability of getting either a face card or a heart, right? So you have all the hearts, you have all the face cards, there's the three overlap, and so you remove 3 of them so that you're not double counting. And of course, 3 out of 52, or sorry, 22 out of 52 does reduce down if you divide them both by 2, And we always want to do these in lowest form, so it'd be 11 out of 26. So the probability of getting a part or face card is 11/26, which is just under 50%. Right, 50% would be 13 out of 26, so it's probably in the 45% range, somewhere in there.